So let's see, Scott, are you ready? Do you want to come on out? Are you all mic'd up and set? So at the end of the day, oh, Scott Guthrie, good morning.
Cool.
Welcome back.
Thanks for having me here.
Yeah. So this is kind of where it all started. I mean, can you remember back in 2003, we were at a college, I think maybe Phoenix University. We ordered like 500 pizzas. We ate in the, like, it was really ghetto as far as the user group was concerned. There was like no money involved. I think it might have even been an evening event. It wasn't an all-day event. And who would have known 13 years later, we're still back at it. Thank you for coming back.
Well, thanks for having me. And it'll be similar format to where it was 13 years ago. There'll be some slides, but it'll be mostly me coding on stage.
Isn't it amazing that you have come this far and you still do all the coding? Like, I work for a super tiny, minuscule company, and even I've outgrown like all of the coding and the day-to-day. There are just, so much better brain power than me that's writing code, and I can read it and I can understand it, but I can't actually invent it, if you guys know what I mean. Like, there's a difference between inventing code and then modifying someone else's code, and I'm kind of at that level where I'm modifying someone else. But anyway, where I brought you out is at the end of the day, the Ask Me Anything is probably the most fun part of the day. So if you have some questions and you want to talk about either something at Microsoft or something with Azure, something around .NET, something around football, right? Something around Duke.
Probably basketball, but yeah.
Oh, basketball, sorry. I knew it was Duke something. But Scott has all the answers, and if not, we'll either make something up or defer it. So the Ask Me Anything at the end of the day will be a great show. So that's about my first 10 minutes to welcome everybody. I sincerely appreciate you guys coming out on a Monday. I know it's hard, you're missing work, and we will do our best to give you an entertaining and educational day. So with that, I'd like to introduce my friend, Scott Guthrie.
Cool.
Thanks for coming.
Thanks, Scott. And before I forget, I want to say a huge thank you to Scott Kate for organizing all this event and for having me back so many times, and it's a real pleasure to be here. So in terms of what I was going to talk about today, Scott mentioned we got a bunch of great content that we'll be covering kind of over the next several hours, and I'm going to start off this morning talking about Azure. And I have a few intro slides for people who don't know anything about Azure, and then we're going to pretty much spend the entire morning kind of walking through lots of different services, showing off real code, showing off real apps, and hopefully having some fun, giving you a taste of kind of what you can do with the cloud and how you can take great advantage of it. How many people here use Azure today? Okay, a lot of hands. Okay, great. When I first came here and talked about Azure, I don't think any hand went up. So it's great to see a number of hands. Well, hopefully you're going to see some new stuff as well today. I've tried to put together a couple demos that I've never given before. So hopefully, both for people that are new to Azure and then people that have been using it for a long time, you're going to see some cool stuff you can take advantage of. So if we go back to the slides now, and with that, I'm going to kick it off and talk about it. Yeah, one of the things that and I thought I'd just spend just a minute on at a high level up front is just sort of the exciting transformation that's happening right now really across the industry with regard to cloud. And really the industry is going through a huge transition, and the cloud really represents, we think, kind of a generational shift in computing that's happening. And it represents major changes for everyone, Microsoft included. And pretty much every organization out there, whether you're a startup, whether you're an enterprise, needs to try to think about how do you take advantage of what the cloud has to offer. And for all your existing apps and all your existing systems, how do you move from where you are today to really take advantage and leverage it? And as part of that journey, there's lots of different things you can take advantage of with the cloud. You can use it for productivity tools and take advantage of SaaS-based applications to improve collaboration, say, within your companies. You can take advantage of it for business applications and use it to automate business processes and improve sales and support and other complex tasks. You can build great applications and use it for infrastructure, which is what Azure's all about, and enables you to kind of really connect better with your customers and really reinvent internal processes. You can take advantage of this rich set of data that's being created in the world and really leverage it, not just to store it, but to really reason over it and get true intelligence that you can act on. And then lastly, you got to think about how do you securely manage all this stuff holistically and monitor it and use it end-to-end across your environment. And it's really the combination of all these things that I think make the cloud really powerful. And at Microsoft, we're looking to basically deliver solutions for each of these different categories that you can use completely independently. And at the same time, we've also, whoops, if I click on the slide the right direction, try to compose them together in what we call the Microsoft Cloud, which enables some really great end-to-end integration throughout them and is backed by kind of a global, trusted, and what we call hybrid promise end-to-end throughout the stack. So what do I mean by that? Well, at a high level, one of the things that we've done is taken Azure and our Microsoft Cloud and deployed it all over the world. And so this map here represents what we call Azure regions, which are made up of clusters of different data centers where you can deploy and run your code. And so pretty much every demo that I'm going to do today, and I think I've got 15 separate demos sections in my talk, you can basically deploy here in the US, you could deploy it in Australia, you could deploy it in China, you could deploy it in Germany, you could deploy it in South America, and in fact, you could deploy it in all those places at the same time. And that really is powerful because it gives you the ability to kind of really take an idea and reach a global audience faster than ever before. And it's something really new in the computer space. The other thing that makes these little dots impressive is not just that there's lots of them, but also the size of each one of them. Each of these dots, in some cases, now represents hundreds of thousands of servers. We've got a couple regions that are approaching over 1 million servers just within that one dot. And this gives you kind of unprecedented power to basically scale up an idea almost instantly to be able to reach any size. What I thought I'd do is just show a quick video of what some of our data centers look like and what goes into making each one of these Azure regions. Maybe we turn up the sound? Yeah. Stole the Halo music and put it there. Us server guys need something, exciting. All those stats that we showed, the fact that you can wrap the network cable around the Earth twice, is just actually for one region. And so there's 38 of them now. The video says 36. It's out of date. We're opening new regions almost every other month. Again, gives you kind of a sense of the scale up, size, and capacity that you can do. And a little bit later on today, we'll actually show one example of that. I'm going to create 1,000 VMs, which is roughly, I think about 24,000 compute cores of capacity. Cool thing is I can do it in one line of code. It'll take less than 10 minutes to fully spin up, and I can now manage a huge environment that I could use for a wide variety of different things. And when I'm done, I can send one command, turn it all off, and I don't pay. And just pay by the minute, and so I basically am super cost effective. So that global and that scale, hopefully you get a sense of. The other big things that we focused on in cross-cutting ways, above and beyond features, is how do we deliver all that capacity with a very trusted model that you can both depend on from a security and perspective, but also from a business perspective, know that you can meet and enter pretty much any market out there that you want. We now have more compliance certifications with Azure than any other cloud vendor out there. And so whether you're targeting government scenarios, whether you're targeting healthcare, whether you're targeting e-commerce, whether you need to meet unique regulations in Australia or Europe or the UK, you can depend on these services and take advantage of them to do it. And then the last thing that's kind of pretty special about Azure is the hybrid architecture that it's built with. I'm going to show pretty much all these demos, with my laptop, taking advantage of just these data centers in the cloud that are Microsoft-based data centers. But the reality is if you're not in a startup and you're in an organization, you've got existing systems already inside your own data centers or your own leased facilities that you're taking advantage of. And how do you connect all these things together? And one of the things that we've really strived hard to do is to make sure that you can easily take what you have today, whether it's at the infrastructure layer, whether it's at the application platform layer with things like .NET, with databases, with SQL, all the way up to Office, and really enabled you to integrate them in a seamless way with our cloud platform and enable you to kind of take advantage of the resources regardless of where they're at and really build solutions that can span across all of them. And this gives you maximum flexibility and really helps accelerate the move to the cloud and the leverage you can get from it. In terms of who's using Azure today, we've got about 90% of the Fortune 500 companies now deployed and taking advantage of Azure today. This is just a subset of some of them, logos you might see on the list. And they're using it for a wide variety of purposes. Companies like BMW. Does anyone here have a BMW? Almost no one admits it, which is interesting because the parking lot has them in there. It's a great car. I wish I had one. But anyway, one of the things that they did was took advantage of Azure and went live with the solution about 9 months ago. And basically their idea was, how can we dramatically improve the customer experience of the vehicle? And they went from concept to live production within 12 months. And now the dashboard in every BMW that's sold today is actually now cloud connected to Azure. The mobile companion app experience that you get as a BMW driver, which lets you not just see the stats of your car, but you can even unlock the car directly from your mobile phone, is all connected to an Azure backend and is using to basically control the vehicles around the planet. In addition to BMW, we've got companies like Toyota, Ford, Nissan, Renault, and a whole bunch more that likewise have integrated their vehicles with the cloud and are using this as an example of how to connect better with their customers and really transform the car ownership experience. We got big data companies like AccuWeather, which is the leading weather cloud provider in the world, that have been using Azure for many, many years. AccuWeather, I think, processes something like 14 trillion individual weather data points every single day, and is basically using our data analytics services inside Azure to kind of basically reason over the weather, predict it, and then ultimately tell their customers about it. And what's cool about them is they're not just sort of for end users, which is probably mostly how any of us have interacted with AccuWeather, but they actually expose all their data through APIs so that retail chains can basically predict what's the weather going to be like and use it for supply chain management and for ordering items. And they're used, in process something like 6 billion API weather calls per day from apps all over the world. Companies like Rolls-Royce, if you've ever flown in an aircraft, chances are the engines on that plane are made by Rolls-Royce or GE, or the two manufacturers, and they're actually both on Azure. Rolls-Royce actually got on Azure first, and one of the things that they wanted to do was basically take the telemetry off these aircraft engines, be able to reason again over it, be able to predict likely breakdowns in engines, and enable airlines to proactively do maintenance on top of them, and then also help those airlines optimize their fuel usage. And it's got a great example of not just doing data, but then connecting it back up again to their customers to transform those business processes. If we go back to the slides again. If we can go back to the slides. Yeah. Geico is another great example of a company that's using the cloud, in this case here in the financial services space. If you've seen the great commercials, you can save 15% on car insurance using Geico. If you're doing that, you're doing it with Azure, and they've now moved their customer-facing as well as their business processing systems now to leverage the cloud. Even though they're a heavily regulated industry in the financial services space, they're now running all those systems inside the cloud using Azure. And then last but not least, from the retail perspective, I thought I'd mention Walmart, which is the largest retailer in the world. Again, they're taking advantage of the cloud both for their e-commerce based customer-facing solutions. So if you order the web or mobile app using, say, Jet.com, which they just bought, which is a startup unicorn on Azure, and is now part of core Walmart. as well as in the back end doing processing and supply chain management and all the rich reporting. Again, all that's being able to take advantage of the cloud. And there's lots more. As I mentioned, 90% of the Fortune 500 are already using Azure, and it's driving a huge amount of usage. And this slide here just talks a little bit about some of the amazing statistics in terms of millions of databases, over 120,000 new customer subscriptions being created every month, trillions of IoT messages, and a whole bunch more. What I'm going to do the rest of the day, though, is not talk about why Azure, talk about customers, but instead actually dive into the tech and give you kind of a whirlwind tour of Azure, showing off a whole bunch of, in particular, some of the newer capabilities that you can leverage, and hopefully whet your appetite in terms of how you can take advantage of it, show off some new things, even if you are an existing Azure user that you might want to take advantage of, and hopefully get you excited to do even more inside the cloud. So Azure has a whole bunch of different services that you're going to see over the next 2 hours, ranging from core infrastructure, so you can spin up VMs, and just use this for compute, network, and storage. But you can also then take advantage of what we call kind of more higher level workloads or advanced workloads with managed services that are really tailored for doing things like web and mobile or IoT or advanced analytics and a lot more. And I'm going to, again, kind of cover hopefully maybe not every service, but a whole bunch of them along the way and give you kind of a sense of how you can take advantage of them. One thing I'll just mention, and hopefully you'll see also reflected in the demos, is I'm going to be doing lots of demos. You can use and integrate all these demos with a huge wide variety of different technology. And our goal really with Azure is not to be the Microsoft cloud or the Windows cloud, but how do we really be the cloud for all technologies and all developers? And this slide here just has a small subset in terms of the different technologies that we support. And with Azure, the goal here is really to enable you to take the best of the Windows ecosystem, the best of the Linux ecosystem, and really be able to use it together in a deep way. So a quick show of hands here. How many people here use .NET? How many people here use Node.js? How many people here use Java? How many people here use Python? Cool. I think I'm going to show all of those today. How many people here use Go? One person. It's good. No, it's cool. We support that too. We love it. Great. How many people are using stuff with Docker? Okay. Cool. So hopefully we got a little bit of everything in there today for you, and we'll give you kind of a good sense of what you can do there. So let's get started and actually dive into some code and show off some stuff that you can do here. And what I do is actually start with one of the services that I think makes adopting Azure super, super easy. And it's one of our most popular services and one of the coolest ones out there. And it's what we call our Azure App Service. This makes it incredibly easy to basically build and scale cloud apps, in particular mobile apps, backends, web apps, API apps, as well as kind of logic-based workflow apps. And what's great about Azure App Service is it's incredibly easy to get started. You can use any language you want with it. It supports automatic patching, so you don't have to kind of think of your cloud-based resources as a VM that you have to manage and reboot and patch. Instead, it does that all for you. You can effectively just deploy your app and let us take care of the infrastructure as you do it. And it's got the ability to scale up and scale down with built-in auto scale, and makes it really easy to set up continuous integration and continuous delivery-based options within your environment. And rather than just talk about it, let's go ahead and actually switch to the Mac if we could, and let's kick it off with a demo. If I can, there we go, great. So I thought since there's people not using .NET here in the audience, let's actually start off with a non-.NET demo. I'll do lots of Visual Studio and other .NET demos in a little bit. But let's actually start off and just build an app from scratch here on a Mac, and then basically create an Azure app, deploy it, and host it entirely in the cloud. So quick question here. So let's go ahead and create this app. What do you want to call the app? My app, okay. Okay. Oh, and there's already one called My App, believe it or not. Your app, there we go. There's not a your app, no, there is now. Okay, So we got a here app here. And so let's just use Node.js. And let me, just so you don't have to watch me type hello world. Also, so I don't screw it up. I'm just going to paste that in. So you can see here, this is literally hello world in Node.js. And so I'm basically just outputting hello world. What do you want me to output instead of hello world? Hello Phoenix. There we go. Okay. So we got hello world, or hello Phoenix, I guess, going here just to test it out. We'll go node server.js. Let's go ahead and localhost it. Hello Phoenix. So got a node app. You're easy. Okay, well that's good. Cool. Easy's good. So let's go ahead now, and it's running locally. Let's deploy it into the cloud. And so what I'm going to do here is use the Azure Management Console to basically go ahead and create what's called an app service in the cloud that I can go ahead and deploy this Node.js app into. And so I'm going to go here. I'm going to go ahead and say new web app. And we're going to call this your app Phoenix. Let's see, hopefully no one's taken that, great. I can choose what's called a resource group. This is basically just lets me group my projects together so I can easily delete everything I create during this demo later. So I'm just going to name this resource group SkyGoo Phoenix. And then I can pin this to the dashboard. I'm going to go ahead and hit create. And what this is now doing is basically just called a REST API in the Azure Management System and said, create a new web app. I can't remember where I deployed it, but I think it was in the central part of the US. There we go. Your app Phoenix is now created, and this basically by default opened up what's called a resource blade inside the portal, which basically shows me all the settings and effectively enables me to manage this app in a pretty easy way. And now I want to deploy this. There's a couple different ways I could deploy that Node.js app. I could use something like FTP and just copy the bits up. But I could also take advantage of sort of source control based deployment, which makes things a little bit easier. And so that's what I'm going to go ahead and do here. So I'm going to click what's called deployment options on the portal. And I'm going to say, let's go ahead and deploy this from, say, a Git-based repository. Now, I could point to GitHub, I could point to VSTS, I could point to Bitbucket, which are three popular source control hosting repositories out there. In this case here, I'm just going to make it a local Git repository to make it super easy. I'm going to hit setup. I've now configured this Azure App Service to basically support Git-based deployment. I'm now going to go ahead and copy the Git URL. We'll go back into my project here. Whoops, let's cancel the local one. So I got my server.js file. I'm going to initialize Git in this folder. I'm going to add that file. I'm going to commit it. Checked it in. And then I'm going to go ahead and add a remote endpoint here, which I'm going to name Azure. And I'm going to basically paste in that URL of that Git endpoint that we just configured for that app inside Azure. And then all I need to do is say git push Azure master. And enter my password once, and then I'll save it locally. It now just went ahead and it's uploading that server.js app, deployed it inside that Azure app instance. I go back here now, click the URL on your app Azure, and hello Phoenix is now running, deployed in Azure. And what's nice is because it's source control based deployment, if I want to make a change here, where is my font is so small I can't actually see VS Code, so I'll just launch it again, I guess. There we go. So I want to say hello Phoenix again. I could do that. I'll just say add that file, updated text, and then again push Azure master. This is now going to redeploy just the changes there, deploy it again back in Azure. go back here and hit refresh, and you can see the changes now live instantaneously. And if I go back into my Azure system right here and hit that deployment options, what I'll actually see is all the deployments that I've done. I can even, if I wanted to, go back and roll back to that initial check-in if need be, and make that again live. And as the system runs, in a couple minutes, you'll start to see requests and error data start to populate, so you can get kind of a real-time view of how the system's working. And I'm now in the cloud, able to start taking advantage of that from a deployment perspective. And again, I can leverage Node, I could leverage .NET, Java, PHP, Python, Go, and more as part of that system and that deployment. So that's a super easy way to get started. In this case here with Node, and we're using the command line and doing everything 100% on a Mac. Let's now switch over to the PC and actually show that same experience that we've also integrated, not surprisingly, inside Visual Studio as well. So what I have here is, again, that same dashboard, and you can see, if I hit refresh, somewhere there, my SkyCube Phoenix app. And all I've done is basically already created a SkyCube Phoenix .NET app here, that, again, using the same approach of new web app, and just deployed it. And here is my simple MVC app that I've loaded inside Visual Studio. If I wanted to, I'd go ahead here, and instead of your application, I could say, hello, Phoenix in .NET. And if I want to go ahead now and publish this into Azure, I could do the same approach of just checking the source control and then do a git push. We've also then just integrated inside Visual Studio the ability to do what we call the publish wizard. And so in this case here, I can go ahead and take advantage of this nice publish wizard, basically select where I want to go ahead and deploy this. Just hit publish. And this is now going to directly inside the IDE, do the build, upload the diffs and the changes, and configure it on that particular endpoint. And what I should see here, again, in about 5, 4, 3, 2, 1, 1, 1, 1. This is the first time I run .NET on this server, so this will take just one more second as it's loading. But what I'm going to see here, come on, pretty darn quickly is, don't fail me now, what's going on? There we go. The app's loaded and deployed, and lightning fast. And so, anyway, that's sort of the simplicity of, from a Node experience, from the .NET experience. This is the full .NET, so this is the full framework that I can take advantage of. Again, how easy it is to basically get started and, again, manage all this however you want. Now, a couple other cool things about App Service. How many people have used App Service before? Okay, a number of people have. Let's show off a couple features, including a few that you maybe haven't taken advantage of, that also make this thing pretty compelling. So one thing you might have noticed if you're new to App Service is I didn't actually have to specify a VM. I didn't have to create a VM. I didn't even have to say really what size or number of instances I want of this. So I can just say create a web app, deploy it. And again, Azure handles more of those things for me. One of the things I can do, though, is I can go into the left nav of this resource, and there's a couple of different options, one of which is what we call the scale out option that I can go ahead and select. And what this basically is giving me is control over how many VMs under the covers Azure is going to basically take advantage of as it's scaling out and deploying these resources. And so right now, by default, it's just one. But you can see I could scale it out. So if I want to run this on, say, 4 VMs, all I need to do is just hit save. And this will now deploy that app across 4 VMs, automatically wire up the load balancer for me, and give me kind of a full scale-out solution for this application, again, regardless of what language it's stored in or written in. The other thing you can do and take advantage of that we highly recommend is something called auto-scale. And what auto-scale gives you is the ability to scale out either based on a schedule, so you can say in the morning, scale it out to 4, in the evening, turn it down, or you can just go ahead and say, scale it out based on a CPU load perspective. And in this case here, I can say I want between 1 and 4 VMs. And what I want to do is run my VMs between, say, 20 and, let's make it roughly 80% CPU. And what this means now when I hit save is whenever the CPU goes above 80% on any one of my VMs, or in aggregate across the VMs, it's going to go ahead and add another VM into the pool up to a total of about 4 VMs, or whatever I configure it to be. And then anytime those VMs drop below 20%, it'll turn off a VM to be able to bring down the load. And that way I can basically handle increased load as customers visit me, but I can also save money because I can turn off resources automatically when they're no longer needed. And you probably saw that little toast that popped up. It's configured and already set it up. And so that's basically how easy it is to get going. And I just noticed there's a lot of, the screen does not look super clear above me here. I don't know if there's a thing we can do backstage because it's a little fuzzy on the text in a way that's not on my laptop. So I think somehow we're got a resolution issue that we got to debug there. Anyway, so that gives you kind of a sense of autoscale and hopefully what you can do there. Let's look at a couple other options that you can take advantage of as part of this. So, yeah, it's only on the big screen. The monitor there doesn't have a problem. The zoom is clear? Got it. So that's clear. Now we'll just do the whole presentation looking through a straw. I'll tell you, I'll zoom in a couple times, and then maybe what we'll do is play around with a different resolution, because maybe there's a challenge there. And so we can try a different resolution in just a second. The other thing I'll just mention, or actually maybe why don't we just do it right now. So folks backstage, I'm going to do a live try to change the resolution on the fly, which will be exciting. 1050, 1490. There's consultation going on backstage, so let's just quickly. Let's see, does that help improve it? There we go, that's better. It's a little smaller, but it's better. Does that work okay? Okay, I got thumbs up backstage. Okay, so we're gonna try that now so you can actually see what I'm doing better. That's still good. Okay, great. So I showed off kind of auto scaling. Let's show off another kind of cool feature that even, we see it for a lot of folks that have used app service before, often don't know about and want to be able to take advantage of. And that's a feature we call deployment slots. So, how many times have you ever deployed something live into production and realized that you had a bug? Only one guy. Let's all look at that one guy. You've had bugs. It's never happened to me, but I've heard other people have run into it, but no. So, one of the things that you want to be able to do in that type of environment is be able to easily test your app before the rest of the world tests it for you. And then when you have a problem, how can you very quickly roll back an update so that you can respond as quickly. And so one of the cool features that we have built into app service is something we call deployment slots. And you can click on it here, and basically you can see that you can have what's called a deployment slot here that you can optionally deploy into, which is sort of a private URL that you can test, but it's running on the same infrastructure as the rest of your VMs, and then you can basically just push a button and say swap the URL in order to actually make that go live. And so in this case here, I've created a staging slot. I could create another one if I wanted to and give it whatever name I want. So you do call testing, you could say previous version, you could basically name it whatever you want, but we're just gonna call this one staging. And then basically when you go to deploy something, so let's go ahead and change this code. So instead of in .NET, we'll say new version, just to sort of simulate what a new code change would look like. When I go ahead now and publish, one of the things I can do is actually, instead of publishing into the main production endpoint, I could go ahead and select on this project. And you'll notice here when I hit deployment slots, that staging option is now visible. And so I can go ahead, If I can figure out how to hit enter. There we go. Yeah, this is good. This is clearly not a resolution I am used to running at, so let's now auto-hide the taskbar. Is that? No, I don't think that's the one. How do we auto-hide the taskbar? Oh, that fixed it. Right-click settings. No, on the taskbar. Okay, there we go. Scroll down. Automatically hide the taskbar. There we go. Oh yeah, there we go. Okay, perfect. So now I can deploy to the staging slot. Thank you. I'll be here all day. So we're deploying a new version of this code, what we should see here once it finishes copying the code is it's going to basically deploy. If I go back here to the original version and hit refresh, what you'll see is ScottGuPhoenix.net, .azurewebsites.net, it just rolls off the tongue, is still the same version. And if I go ahead and click About, it's still got the original version of the code running. But what's happening is basically we are deploying that new instance that has the code change in that staging slot. And what I should see here in just a second is the new version deployed. But you'll notice the URL here is scottguphoenix.net-staging. And so only I know that URL, and you can make it a GUID or something to hide it. And that way I can test it out. I can make sure everything's working on the actual environment that I'm going to run this on. And then when I'm ready and sure, yep, the code is ready to be used, I can go ahead and just go ahead and hit swap. Tell it to swap the production and the staging version. Go ahead and hit OK. And this is now going ahead and actually changing staging to be production. And we'll actually then make production and take it back to make it staging. And that way I can keep the previous version around so that if I do have a bug, I can very quickly reswap it back and have it be the live version that everyone sees. So that one now is in the process of swapping. So you can say, hey, the swap is in progress. Usually this takes up to about 30 seconds to do, except when I'm doing a keynote demo, in which case sometimes it'll take 60 seconds. And hopefully what we'll see here is in another couple of seconds, the swap will be done, at which point we'll be able to hit refresh and actually see those changes live in production. It will happen, don't worry. There we go, it's done. Great. So now this is the live version. I hit refresh, and you'll see the new version is now deployed with the live URL. And if I go back to the staging version, so this used to be the new version, but if I hit refresh, you'll see in just a few seconds, it's now the old version. And so basically, I now have my changes live in production. All existing people using the new URLs are seeing them, but the old version is still around. So if I realize, oh, I made a change, panic, hit a button, it'll swap back, and I won't have had any impact in terms of customer experience. So nice, cool feature to take advantage of. Other really nice thing about this is you don't pay extra for it. It's just built in, and you're able to take advantage of the same set of VMs and the same set of resources that you're using for your production app. And so it's a really nice way you can add quality into the system and take advantage of that, again, that cloud elastic resources to do it. Other couple of things I'll just quickly mention, and then we'll move on and talk about some more stuff, is built-in networking support. So you can take this web app and join it as part of a virtual network now. You can also connect this web app back to any on-premise resource that you might be taking advantage of. So we have a lot of customers, as an example, who have, say, a database back on premises or an existing system they need to integrate from an API perspective. No problem. You can go ahead and expose that through a private virtual network to Azure, and then take this web app and basically seamlessly connect it all in a secure way and be able to access and leverage those resources. You can do SSL, you can do custom domains, you can do a whole bunch more. And again, the great thing, as you hopefully have seen, is it's pretty easy to take advantage of this and leverage it in a really rich way. So that's a little bit about app service from a basics perspective. Let's go back to the slides now and talk about a few other things that we could do with this. So the thing I want to show off next is, we demonstrated how easy it is to deploy things just by kind of pushing it into production directly from our dev environment. The reality is, as you're building apps, though, in the cloud, and even as you build them on premises, it's often not ideal to directly from the developer's machine just actually push code up into a production environment. Instead, it's much better to set up kind of a continuous integration workflow that enables you to kind of repeatedly check in code, build it, run tests against it, potentially do kind of more advanced release management sign off, and then ultimately push it into production in a completely automated way. Makes it possible to work across the team, and it provides a sort of set of quality gates that hopefully also ensures that what you're doing is ultimately going to be repeatable and reliable as you scale. Anyone here set up continuous integration today? Great. One of the things that we have built into Azure is a variety of different ways that you can do CI/CD. And I'm going to show off a couple demos of just a few of them. They start from the simple basics like we did on the Mac there, which you could just sort of git push effectively into a repository that we maintain for you, code. The richer set of scenarios we enable is with something we call Visual Studio Team Services, which enables you to not only kind of push code into a repository, but also does build and testing for you in the cloud. And what's nice is, similar to app service, instead of you having to set up VMs to manage all that, we provide them as managed services, which basically means we'll spin up a VM that is a build server, we'll do the build, and then we throw away the VM after you've done the build. And you're not paying for a VM that's sitting idle lots of times during the day, and you're not having to wait for that VM to spin up, since we maintain a pool of build servers that are ready to basically be allocated to you as soon as you kick off a build. Similarly for testing, we also now have lots of test servers running in the cloud. So all you need to do is upload your tests, whether it's with XUnit, InUnit, your favorite Java or Node or Python-based testing framework. We can basically run them for you. And again, you don't have to manage or maintain that infrastructure. And we also do load testing. And so if you want to be able to simulate, let's say, 250,000 users hitting your app, we can basically throw a lot of load from a bunch of machines and effectively simulate that load for you, so you can measure, again, for both performance as well as availability as part of that. So what I thought I'd do is actually show off how easy it is to set that up. So rather than just describe it, again, let's use the principle of let's show, not tell, as part of it. So one of the things you can do here if you want to set up continuous integration is on any app service that you create, and it's best to do it on a new app service environment, although I think we probably could clobber the app we had before, but let's just start off with a new blank app service endpoint that I created last night. There's a way that you can effectively wire up CI/CD with pretty much any system out there. One of the things that we've got in preview now and just launched about a month or two ago is a continuous delivery option that shows up directly in the portal, which helps automate this process and makes it a lot simpler. And so if you go ahead and click it, it brings up a nice little wizard here that you can basically use to connect up to your code, set up your build environment, your test environment, and then also set up the publishing rules for how it's going to be basically deployed into the cloud. And if you go ahead and hit configure, it'll walk you through a nice little wizard to set that up. One of the things you can do as part of this is choose from a variety of different source control repositories. So for example, you could connect to VSTS, which is our rich set of developer services in the cloud. But you notice you can also connect to GitHub. So if you just have a GitHub account and you've got a GitHub repo up there, you can go ahead, select the GitHub option, point at the repo. We'll do kind of an OAuth single sign-on check with GitHub for you. You select the project, and then now you can have that be your source control repository. So you don't have to move your source control over to VSTS. You can use GitHub, and we'll add more options over time that you can leverage as well. What's nice about this, though, is it doesn't just pull your source, but it can also go ahead and automatically set up a build and test environment. And what's nice is about VSTS is it's fairly pluggable. So you can use VSTS as an example for your source as well as your build and test. But if you select GitHub, you can also use GitHub as your source, and then VSTS can set up a webhook with GitHub and can build and test your code even if it's actually hosted inside GitHub. And so you can basically choose how you want to set up CI/CD in a pretty flexible way. You can set up Jenkins, you can set up any other type of environment you want. In this case here, I've got a project inside Visual Studio Team Services called CI Demo, which, if I look at the code, it's just an MVC project and a set of tests. I'm going to go ahead and set this up to basically enable CI/CD with Azure. So I'm just going to change to my Scott Guthrie account. I'm going to point to that CI Demo project we just looked at. I'm going to use the CI Demo repository in the master branch. Hit OK. I can then go ahead and select what framework I want to use. I could use ASP.NET or I could use ASP.NET Core because it's detected it's a .NET-based project. If I was using Java, if I was using Node, I could use the appropriate framework there. I could optionally do a load test. So basically, instead of when a change happens, just deploying it into Azure, I could actually say, as part of my CI/CD pipeline, please test it with, say, 100,000 users. But I'm just going to go ahead and hit deploy for simplicity. And you'll notice I can also go ahead and deploy into staging. So instead of deploying it live, I could do just like what we did manually when we deployed into that staging production slot and have my changes go live there, and then do one last minute manual check, and then hit a button to make it swap into live. So lots of full flexibility in terms of how we configure it. Just for simplicity, I'm just going to deploy it into the main slot. Going to hit OK. And what this is now doing is wiring up a full CI/CD pipeline with Visual Studio Team Services so that every time someone checks in code to that CI demo project, it'll build it, it'll run all the tests in that project, and assuming they pass, it'll go ahead now and deploy into the production slot inside Azure. And you can see now it's fully wired up. I can now go ahead here and oops, oh, look at that, that's cool. Let me open up a project here. I'm going to go ahead and just make a quick change here. We'll call it my Phoenix app. Going to go ahead and commit that change. Updated text. Go ahead, commit and sync it. And this is now basically committing it to my local repository, and then it's pushing it up to my master branch. In this case here, it's with VSTS. Again, it could just be with GitHub or any other source control hosting account. And now, if I go back here, what I'll find is this is where my source control is. If I click inside here, I should see just now updated text. I can't remember what text I changed. There we go, my Phoenix application. Or Phoenix app, I've changed one of them. And if I go ahead here now and click build, what's happened here, if I can also shrink my browser down, this has gone ahead and queued up a build that's now running automatically because of that change. And so you can see somewhere right here, it says it's in progress. So we double click it. I can actually see I'm position 1 in the queue. I'm using the free version of VSTS, so there's a lot of people apparently doing builds right now. And so hopefully, since I'm position 1 in the queue, as soon as available build agent server is ready, it's going to go ahead and start building this change that I just checked in. And once it's done, it'll go ahead and automatically start pushing out. Oh, my mouse died too now. We're having lots of fun technical issues today. There we go. You can see build server just became available. It's basically syncing the code change that I just checked in. It's going to basically be compiling it. You can see it pulled down all my .NET assemblies from NuGet automatically. Just finished the build. It's now running the tests. And assuming all those tests succeed, it'll then go ahead and push it into my Azure App Service in a completely automated way. And what's nice about this is not only is it building and testing it, But I can also go ahead and, if I want to do something even richer, is instead of just having kind of this automatic pipeline that I've created, I'm just kind of waiting for it to publish. So you can see it's starting to upload it, published, it finished. Great. So we'll check that in just a second. But you can also go ahead and, if I wanted to customize this build even more, I could click Edit. And one of the things it gives me is that build pipeline that Azure just automatically set up for me. But if I want to customize or add additional tasks, I could easily go into VSTS and change it. So for people in the room that are using Java, I could use Maven, I could use Jenkins, I could use Ant, I could do Android, I could do iOS builds. We even have a Mac build environment now, so you can actually compile your iOS apps. And basically it provides, again, a really easy way that you can configure all this. And if I go back here now and hit refresh, what I will see in just a second, although that might have been deploying into the initial check-in here. You can see basically the check-in that just happened, and this basically now is live in production, running through that full CI/CD pipeline process as part of it. So really easy way you can effectively set up a CI/CD pipeline automatically, again, from code that you might check into VSTS using Git or TFS, or you can go against GitHub or go against any other source control repository out there, and again, set up this full production end-to-end workflow that you can take advantage of, and now have a repeatable pattern that you can run throughout your process in a safe way. So that's a little bit about app service. And hopefully you saw here, if you're an existing developer using pretty much any language and code, it's easy to set up, easy to scale, easy to use things like production slots, and by taking advantage of our built-in CI/CD pipeline stuff, easy to set up in a repeatable way that you can leverage on an ongoing basis. Let's switch gears now and talk about some other services that we have in Azure. And in particular, talk about kind of a trend that's pretty hot right now that many people in the audience might have heard of, called serverless. How many people here have heard of serverless? Great, okay, a number of people have. You know, the idea behind serverless at a high level is, you know, how can you take advantage of increasingly sort of higher layers of abstraction as you build your applications, so that, you know, while app service abstracts away all the infrastructure for you, there's still a VM running there at a logical level that you're scaling up as you're running code. With serverless, you don't even have to have a VM. Instead, you can just sort of have a very small task that you can say schedule to run at a particular event or a particular time, and it will automatically schedule that compute on available resources without you having to have any resource sitting around that you're actually paying for when that task is not actually running. So we can switch back to the slides here. Let's talk about a cool service that we just went general availability with called Azure Functions, which lets you do that and really take advantage of a serverless compute environment that's really powerful. You can trigger these sort of serverless tasks that we'll write to basically happen anytime you want. So you could have a timer and say every 5 seconds run this job, in which case the other 4 seconds or 4.999 seconds that it's not running, you're not paying for anything. You can also set it up so you can say when someone uploads something, say, into the storage system, or when some event happens inside Azure, automatically run this code. And again, you only pay for the execution of the code when it happens. And you can use a variety of different programming languages. So you can use C#, you can use Node, you can use Java, you can use Python in order to write these serverless functions. And with that, let's go ahead and switch back to the demos and actually show what this looks like in action. I think we're done with that. So what I'm going to go ahead and do is load up an Azure function that I created earlier. And I basically created it the same way that I created an app service. I just went new Azure function. And this is basically creating kind of opening up an environment I can use to basically edit functions as well as monitor, manage, and run them all using the browser. We also now have built into VS 2015 a nice project support, so you can also edit them directly inside Visual Studio. That does include both debugging support as well as deployment support. And then you can also wire up functions to take advantage of that same CI/CD workflow that I showed off both originally on the Mac just directly as well as with VSTS or GitHub. So you can also use source control to deploy and manage your environment as well. But the browser-based editing makes it easy to actually get started. And for a lot of cases, you know, when you're just sort of playing around with it, provides a really nice iterative model that you can take advantage of and use. So let's create a function. And so the easiest way to get started is you just go ahead and say, create a new function. And let's go ahead and create, let's say, a simple HTTP-based trigger. And so we'll call this, what do you call it? HTTP trigger in Phoenix. Go ahead and create. And what this is doing is basically just creating a new function for me and registering it with the system. And you know, it puts in some little stub code here that we'll look at in just a second, where you can basically pass in a parameter and it just outputs the parameter back to the user. So pretty simple approach. Go ahead and run it. I can basically take the URL here for the function, paste it in, and you'll say, hey, pass a name on the query string or as a parameter. So I'm just going to go ahead and say name equals Phoenix. Oops, we'll spell it right. And you can see here, it just spat back hello Phoenix as part of the payload response. So super simple way you can go ahead and create a function. And again, as part of the environment here, we have a nice little interactive debug window that you can actually use to kind of see how everything's going. And again, I can edit everything directly in the browser if I wanted to, or again, load up Visual Studio as I get a little bit more advanced in order to write this code and run it. Now what's nice is I can write functions though in a variety of, or I can fire event functions off in a variety of different ways. So directly in response to an HTTP request is one way. But I can also set up what's called a timer-based function, where I could just say, run it every 5 seconds, execute this code. And so if you've got kind of a background set of tasks that you want to run, and you don't want to have to kind of figure out how do I activate my web app, and basically, I have a function last night that I had a code error in, so it's kindly telling me I have an error, but it's going to occasionally pop up there. Don't worry, that's not a bug in the code we're writing right now. But this timer thing can basically run in the background. The other thing I can do is, that's kind of cool, is I can wire up a function to fire in response to what's called a webhook. How many people here know what a webhook is? A number of people do. So a webhook is basically a way you can stitch together multiple systems using kind of an HTTP request response-based pattern. And so, for example, a lot of popular SaaS apps provide the way for you to register a URL that they'll call in response to a particular action. How many people here use GitHub? A number of people here use GitHub. So here's a simple example of how you can use Azure Functions with GitHub. So you can go ahead and say, create new function. And there's a built-in template here somewhere called GitHub. There's a C# as well as a Node.js version. So we're going to call GitHub webhook in Phoenix. And basically what I want to do is take this, create it, and I'm going to set it up so that anytime I check in code into GitHub, or anytime anyone sends an issue into GitHub, I want to basically run code as an Azure function. And the nice thing about the GitHub integration that we have is it's really easy to do that. Basically, we're just going to take this function URL, copy it, go into GitHub. Zoom it out so you can see a little bit more. And then on any particular project you have in GitHub, just go to the settings, click on webhooks. That was the one I tested last night. I can then add a new webhook, paste in the function URL, and then GitHub has the notion of a secret, and we've helpfully give you a secret, which is not very secret right now, but and I can basically say, hey, GitHub, just send me push events for certain types of things, or let me select individual, or in this case here, I'm just going to say, anytime something happens in this project, go ahead and fire that webhook. And so now, if I go to my issues list, let's go ahead here and make sure this is running. Great. If I go ahead on the issue, and I just go ahead and say, new issue, click comment. So this is running on GitHub. GitHub saw that, called that webhook back in my app. And what you'll see here is it just processed a request, and somewhere down here, assuming I got everything right and GitHub's working, it'll basically fire off inside here. There we go, it just fired it off. A quick little message that said the request was processed. You might be able to see it right here. And it basically just triggered that request. Now, my request right now is not doing anything, but I could obviously go ahead and, oh, that's not the right request. Hold on. GitHub Phoenix sample. And this basically just fired off the request, from GitHub, triggered it, and now this code that I just wired up is now executed. Now, right now my code doesn't do anything, but you can imagine, for example, putting in code that fired off a pager alert, sent off an email, or did something else to basically take some action. Again, that's how easy it is to effectively create a function, wire it up as a webhook, not just to GitHub, but to any system out there, and be able to kind of process code in response. Last kind of cool thing I'll just show off with functions is how you can not only integrate with webhooks, but you can also integrate with any of the services built into Azure itself. And so we have a notion of click on the integrate tab inside a function. You can say, register a trigger so that, for example, anytime that something gets updated inside my Azure Blob account, which is a storage system we have in Azure where you can save any type of file, go ahead and actually run a function. And so in this case here, this function is going to take whatever was stored in that storage account, and if it was an image, it's going to go ahead and take advantage of a set of APIs I'll talk about later. We call our Vision APIs, which is one of our cognitive service APIs that are built into Azure. And this is then going to go ahead and say recognize any text embedded inside the image, pull it back using a link query, and then basically store it inside a NoSQL database inside my account. And what I should see here, if I can minimize everything, is if I can now go ahead and click Edit. I never tested this before. What would you like me to say? Don't say hello, Phoenix.
Hey, yo, what's up?
Hey, yo, what is up? Okay. I said anything. So we'll just rename this something else. And somewhere in my straw here. There we go. I'm going to take advantage of a tool that works on Windows, works on Mac, works on Linux, called the Azure Storage Explorer. Makes it really easy for you to see what's in your blob storage account without having to write code. And we'll see what this looks like when it's zoomed in extraordinarily large. But in theory, I should be able to go ahead here, copy this here. This is now uploading that image into my storage account. Let's minimize that, and now we'll go back somewhere inside here. This trigger just fired, just to prove it's real. It called, in response to that blob, called that Vision API. It did automatic text recognition on that image. Hey, yo, what's up is there. I wasn't sure if it had like proper English text or something, and it was going to get stuck on yo. It's good to see that it worked. And again, the beauty about all this stuff is I'm not running VMs. I'm not having to pay for any VMs. I'm basically paying, like 1/1,000,000th of a penny per whatever second or something that's running. And so it's super cost effective. And if you've got some occasional tasks, it's a really great way you can run code. If you've got lots of tasks that are running all the time and you're basically always using that VM, we also have a nice option where you can basically say spin up some dedicated VMs just for my functions app. And so if you're worried about variable cost, if you've got tens of millions of function requests, that's a nice way that you can also reduce the cost if you know you're going to use at least a certain amount of capacity, which is a nice option that none of the other cloud providers have. So you can use that dynamic option, again, pay just by the function invocation and the amount of CPU you're using, or you have that ability to even have a fixed pool of resources dedicated to your use cases. So that's a little bit about functions. So let's go back.
Super nice with functions. I'm using them for to process Stripe payments on a GitHub static page. So it's easy to make a call in, process the payment, and come back. So basically, I'm not having to pay for any server hosting because the static website's on GitHub, and Price, as you know, or Stripe, as you know, has a callback function required. You have to have a server to process it. I'm in love with Azure Functions. It's my new latest and greatest thing for the last 3 or 4 months.
We'll issue a couple other things to fall in love with related to serverless. And then a little bit, we'll just do, maybe like 5, 10 minutes, we'll do a break. And that's sort of logic apps. How many people here have used logic apps? Cool, fewer hands, good. Well, not good, but it's good because you're gonna learn about stuff. It's a cool service we have. It just went GA, a bunch of the functionality a couple weeks ago. And it's another example of these sort of serverless-based option that you can use independent, but also integrates really nicely with functions. And the nice thing about logic apps is, the nice thing about functions that you saw is you can write any code you want. And so you can add if statements, you can add workflows, you can do a bunch of stuff all through code with functions. The downside though is you're writing code. And for some set of scenarios, it's nice to be able to kind of more easily have a workflow and ideally a built-in set of connectors that you can leverage to kind of automate your code. And that's what Logic Apps provides. And so with Logic Apps, it makes it really easy for you to wire up events and or integration workflows across a wide variety of different resources. So we go back to the slides real quick. So you can connect to your SaaS apps that you have in the cloud. You can connect to on-premise systems, so like SQL databases or SAP systems or other CRM system of records. And you can also integrate with cloud apps that are out there. And then you can set up sort of a serverless workflow. We automatically scale and run the code and the workflows that you're executing for you. You don't have to you don't have to worry about the VMs. And you can use them to kind of orchestrate some rich, complex tasks. So let's go ahead and see what this looks like in action. So I'm going to load up a Logic app here that someone on the team built for me. And it's called the Twitter Analytics Logic app. And basically what this app does, you can kind of see it, we'll load into the designer so you get a better sense of what it's doing, is it's basically setting up a workflow that includes calling out to some Azure functions using the same mechanism we saw earlier that fires in response to anyone posting something on Twitter. And so basically, you can see here, using the designer, you can create kind of a nice GUI-based workflow. So this is searching Twitter for tags or posts, tweets that have the hashtag Azure in them. You can see we're checking every 15 seconds. We're then calling out to another one of those cognitive services that I'll talk about a little bit in the future called sentiment analysis. And so we're basically running the tweet through machine learning to actually see what are people saying about Azure and basically calculate the sentiment of it. And in particular, we're looking at the text that they tweeted. We're then basically running through Azure Functions some additional processing to look for also key phrases. Are they talking about price? Are they talking about, hey, how do I do this? I'm stuck. I need a sample. And so I can write some custom logic as an Azure function that Logic Apps is just calling out to. And then basically, we're populating the results into a Power BI data set. And you can see here we're populating this thing called real-time table. Here are all the different values we're pulling out. So we're pulling the tweet, we're pulling the score of the sentiment, where it came from, when it was created, and then from the function, we're pulling out the body that was returned from the function as additional data that we're storing inside there. And then, since we don't want to just populate a database, we might want to take some action. We basically have a condition here that's workflow, where for the score, if it's less than 0.3, meaning it seems like someone's really upset about something, we're going to basically go ahead and post it into our Microsoft Teams account. You could also, we have a Slack connector as well. So to basically say, hey, this user over here in Ireland just posted something, here's the URL to it. And that way the team can quickly respond back and say, hey, can I help you out? And it's all kind of a nice automated workflow. And what's cool is if I wanted to add another step, I could easily do it. I could add a condition, or I could connect to any number of adapters. And we literally have over 90 adapters today. So I could go to my CRM system, whether it's Dynamics or Salesforce. I could go to DocuSign. I could pull data from a database, whether it's SQL, DB2, Oracle, Postgres, MySQL, et cetera. And I could do something with MailChimp and so forth. So really rich set of adapters that are all pre-built for me that I can leverage and I can basically take advantage of as part of this workflow. And the end result is, this is now running. This is the Power BI dashboard showing the different sentiment that's happening. Now Azure, unfortunately, is used for many things, so we often see like, hey, my Louis Vuitton bag isn't available in Azure. You can see there's an Absolute Vodka, great marketing, something to do with Azure Days. I think that's spam. You know, jobs in Birmingham, Alabama, that's great. I can also see where people are tweeting around Azure around the world. And then here is that Microsoft Teams space. And you can see here, oh, there's a guy who says Azure's networking is fundamentally broken. That's great. Again, we're only showing the negative ones here. So we'll see. You know, the list of Azure services available in UK data centers keeps on growing. I don't know why we thought that was negative. That seems good. But again, yeah, it's an example of where our logic when we built that, you know, wasn't quite right. But you know, I've even think, you know, anyway, so you can sort of see these are the ones that there's good one. Banging my head on Visual Studio Azure deployment. Only to find out all you had to do was reload the project. Great. Okay, good. The guy was happy in the end. But anyway, it gives you kind of a sense here. Again, we're searching all of Twitter. Twitter is a wonderful thing. But it gives you a sense, again, how you can create this workflow. You can set it up. Again, it's serverless-based computing in action. You can take advantage of all these built-in connectors. You can call into Azure functions or any other API you might want to run in a VM or even inside, say, something like App Service. And there's another cool option. If you haven't checking it out, we're taking a look at. And these are all the built-in connectors that we have today. And we're adding more and more connectors that you can leverage. And you know, Logic Apps provides a fantastic way to do really rich integration, really rich workflow, and you can go ahead and run some custom stuff. So last thing I'm going to show before the break is talk quickly about containers and Docker, and then we'll do a break in, again, about 8 minutes, if that works. And then I'll come back in a little bit as well. So let's talk about containers and Docker. How many people here are doing container-based development today? Cool. A couple of people. How many people have heard of container-based development? Great. How many people have heard of Docker? Great. How many people here think they're going to see Peter Pan? Okay, great. Okay, just double checking. You're like, what is this talk? So, you know, obviously containers and Docker are really top of mind for a lot of development teams right now. And one of the things that we're doing is investing very heavily in making container and Docker-based development work not just great with Azure, but really across all of our different products and services. And with .NET, you can now go ahead and containerize any .NET application, both .NET Core applications as well as full .NET Framework applications that you might have started writing, you know, 10 years ago. And you can now go ahead and containerize those applications and then easily deploy them into Azure, into a Windows Server 2016, which has built-in container support out of the box, as well as to other environments like Linux. In fact, you can take a .NET Core application, containerize it, and push it into any Linux-based environment that supports Docker. And with Visual Studio 2017, which is now available in RC, we have another RC coming out, I believe, later this week. And you'll see the general availability release in the not too distant future. We've got fantastic tooling support built in that enables you to, again, to orchestrate all this workflow. So if you are a .NET developer, you want to get it into Docker, it's never been easier to get started and to be able to take advantage of it. So let's go ahead and build our first Docker-based application before the break. There is a way to make this thing hide. Does anyone know how to make that hide? Settings? Ooh, hidden, or icon, there we go. Oh, my life has changed, thank you. So, gonna go ahead here. Let's create a new project. .NET Core application, we'll call this Hey Cortana. It's Hey Google, right? Yeah, anyway, but Anyway, we got them both in here. So anyway, we're going to create a new Cortana project, and this is a .NET Core application. So this is using the new .NET Core framework, and it's loading it up. Great. And I basically have got my home controller and just a standard .NET Core based project. And so runs just like existing .NET Framework projects, but in this case here using the .NET Core runtime. Now let's Docker enable it. So this doesn't have Docker yet today, but let's go ahead and Docker enable it. So what I can go ahead and do is with the new VS 2017 is there's now right-click on a project, click Add, and there's now Docker project support that I can go ahead and just click. And so if I do that, this is going ahead and at the project, it's going to go ahead and add in a couple extra files. So to add in a Docker file as well as a Docker Compose file. So I can basically orchestrate this Docker-based container image. And so, for example, here is my Docker file. And you'll see it's the same Docker file format that you'd look at if you bought a book or saw any other language project using Docker today. So it's pointing at the ASP.NET Core image, version 1.0.1, and basically creating an entry point of a DLL. And if I look at my Docker Compose file, this is the standard YAML file that's also allowing me, if I have multiple projects, to be able to kind of point out how this container image talks to this container image. And then if I want to try this out, so I want to deploy and run this Docker image, just click the Docker button that's now available in my toolbar inside Visual Studio. So this is doing, for the first time, takes a little bit more time to basically build that Docker image. Subsequent compiles will be much faster. And what this is also doing as part of this is not only building the image, but it's also talking to the local copy of Docker for Windows that's running on my PC. And it's now deploying that image into that environment, launch the browser, and now this is a Docker-based image running locally on my laptop, fully containerized, running .NET, fully wired up. And if I go ahead, you might be like, hey, but how do you debug with Docker? You can't do that with a lot of other languages. That's true, but you can do it with .NET. And so we'll set a breakpoint, go back, go back not to there, but go to here, hit refresh, and notice I've now broken in the debugger, and I've got full support. That's part of this. What's cool about this is not only that it works, and thank you for clapping, but this image here is actually running using Linux. And so this is part of the mind-bending part of what this demo is actually showing is Docker for Windows is running locally, and so it's controlling, giving me a Docker endpoint. For this particular image, because it's running .NET Core, I can actually run it on any OS. And out of the box here in this build, for the default that I've configured, I'm actually running this on a Debian-based Linux running on my laptop. And so what we've done with Visual Studio is actually integrated with Hyper-V, which is the built-in virtualization stack in Windows. It's running a Debian image as a Hyper-V lightweight VM, running Docker. Visual Studio injected that .NET Core application in that Debian image, then connected the debugger, and made all that wired up. And so if you go in the debugger and actually run system diagnostics, you'll actually see it thinks it's running a Linux-based image, or it is running in a Linux-based operating system using my standard .NET Core. Hit continue, and the app just continues to work. If it was a full .NET Framework version, so code that started out again many years ago, I'm using system Windows dependencies, and so I can't run it on Linux, but I can run it using Windows containers, which are built in now to the latest version of Windows. And so I can still take advantage. I still use the same Docker file format. I can containerize that .NET Framework app and still get that same experience and still do orchestration across multiple projects within my solution. And if I did have, say, time, we'd add more projects. And this afternoon, you're going to see more of that. I can do debugging even cross projects within that solution and have everything running in a containerized image. Now, the beauty about this is when I go to deploy this application, I have much higher confidence that it's actually going to work in the environment that I'm deploying into. because all of the dependencies of that application are defined using Docker, and I'm basically copying more of the environment and effectively able to kind of simulate the environment in more totality, which means it's more reliable and I can actually much more easily deploy things into a wide variety of different environments. And one of the things that we're doing with Azure is making it super easy to deploy things using Docker into Azure as well. And so not only can I run this thing locally, but I can also click this little publish button, just like you saw me do with app services. I'm going to go ahead and say deploy this into Azure App Service. This is now going to go ahead and give me the option to create a new app here. So I'm going to go ahead and create it in my SkyView Phoenix resource group. Go ahead and hit create. And this is now creating a Hey Cortana application. These are the previous bits that we shipped 2 or 3 months ago. It's a little bit slower than I'd like. The new bits out this week improve this publishing experience a little bit. Now it's created this new application inside Azure for me. This profiles thing now populates, and what I can do is just hit publish. And same way that you saw me deploy the app service earlier directly from the IDE, I'm now doing this, but this time as a Docker-based image. And this is actually using the full Docker, so you'll notice it pops up this dialog. And in just a second here, you're going to see docker.exe actually pushing the image into a Docker-based container registry running inside Azure, hopefully. And you'll see it push the image soon. This is the Docker part of the code, so this isn't actually my code. Good question. How big are the images? So anyway, so it refers to a repository. Okay. So something's coming. It's usually lightning fast, so I'm not sure the network's having an issue or, there we go. So the nice thing about the images here is I'm not actually having to push everything. Because I've already deployed once .NET Core on that environment, it's actually just pushing up the small set of changes specific to my application. In this case here, it looks like a 17 megabyte file, which something around the network, there we go, it's now speeding up, great. So I think the reason it was a little slow was because of the network. And what I should find is hopefully I'm not having to actually re-upload the OS image or the .NET image. Instead, it's able to mount from an existing image that's already inside Azure. And my Docker file is sort of showing what it depends on. It's able to construct that chain for me automatically. And what I'll hopefully see, assuming the network gods are willing, I'm not sure, maybe it's because we're streaming, it might be uploading, the upload link might be actually saturated. Download seems fine, but hopefully here, what usually is 5 seconds took maybe more like 190 seconds. But what I should see in about 10, 9, 8, 7, it's so close, it's gonna work, I know, it's 6, 5, 4, 3, 2, 1, 1. It's gonna work. Again, on a fast network, this is instantaneous. And what this is basically doing, again, is uploading the image. Azure App Service now has that container support, so it's basically pulling the right images from it. And what we'll see as soon as this thing completes, again, which is the official Docker tool, as part of it is that app's there, and then in just a few seconds, it will load. Shouldn't have to push ASP, that's why it should be so fast. I think what's happening is the network upload link, because we're actually streaming this on channel 9. There we go, it just finished. It was a little slow, and so I think it's just network latency that's happening for this particular connection. My hotel room, that took 4 seconds. And basically now it's pushed, it's uploaded, and again, we should see now, there we go. This is Hey Cortana running in a Linux container on Azure App Service using my .NET Core application that we all entirely built from scratch, even on a slow network. And so anyway, it gives you kind of a sense of how easy it is to get started on this. You can also set up a full CI/CD pipeline. So again, here I'm pushing it directly from my dev machine, which is a great way to frankly get started to take advantage of it. You can also enable more complex workflows, both to Azure App Service, as well as what we typically find as people start using Docker is they might containerize an existing app they have, and then want to be able to build an even richer app that maybe has more microservices. So you might have a back-end shopping cart or shipping service and so forth. You can go ahead and create, say, a solution with those projects, including ones written in other languages. And we've got a full set of CI/CD support with Visual Studio Team Services, as well as you can use Jenkins, you can use GitHub, you can use anything else. We have a built-in what's called an Azure Container Repository that you can run as part of your account. So you can go to the Docker Hub that's public and pull images, or you can cache them locally if you want to not publish, for example, your own code up into Docker Hub. Again, with our Azure Container Service, which is another of the managed services built into Azure, you can now run not just your web apps, but you can also run all of your different services in a microservice-based environment and take advantage of rich orchestration frameworks, including Mesos, Docker Swarm, as well as Kubernetes for both Linux and Windows containers. And as I mentioned with VSTS, we now have full CI/CD support for containers. And what this means is you can go into your build definition, and you can see here we have a whole bunch of Docker commands that you can now orchestrate as part of your build pipeline that enables you to build and test all of your images as part of a standard check-in, and then again, deploy them into the cloud using Azure, including full release management directly to whatever instance you want. So a lot of rich support. You can take advantage of all this. Hopefully what you've seen so far this morning is how easy it is to build apps and code on Azure. We talked about app service, we talked about functions, logic apps, and now containers. What we're going to do now is break for, I think, 15 minutes.